Hello, welcome to the Institute of Microproduction Technology. My name is Rico Ottermann, and today I would like to give you an insight into the process of dicing wafers, which is an essential process not only in our everyday research life, but also for global semiconductor manufacturing. Silicon wafers form the backbone of countless devices. These thin, round slices of silicon are the starting point for making integrated circuits found in every electronic hardware from smartphones to satellites. The majority of the microtechnology systems that we produce at our institute is also fabricated on wafer level. Mostly silicon, but also glass, ceramic and metal. The transformation from a whole wafer to individual chips is where wafer dicing comes into play. By manufacturing hundreds of functional chips at the same time on large wafers, which are only cut to single chips afterwards, the effort and cost of a single chip can be reduced dramatically. The dicing process at our institute involves a high-precision saw equipped with a 2-inch dicing blade. These blades cut with exceptional accuracy, minimizing waste and maximizing efficiency. The thickness of the blades we use ranges from 15 micrometers to 800 micrometers, producing a saw street with roughly the same dimension. The blade is composed of abrasives like diamond or cubic boron nitride, which are evenly dispersed in either a metal or resin bond, depending on the material to be cut. The size of the abrasives also depends on the wafer material. Typically, they measure between 2 and 60 micrometers. Before dicing, each wafer undergoes careful preparation. The wafer is mounted manually onto specialized dicing tape to support and stabilize it during cutting. This ensures smooth, vibration-free operation, preserving the wafer's delicate structure even after the single systems have been cut. Our equipment allows us to execute the dicing process with remarkable precision. With an accuracy of only a few micrometers, a single silicon wafer is transformed into hundreds or even thousands of similar dies. To achieve such precision, factors like blade alignment, cutting speed and water flow rate must be strictly controlled to ensure flawless results. Managing the heat generated during cutting and minimizing blade wear are ongoing challenges. Precision and control are critical in the dicing process to prevent damage to the wafer and ensure the reliability of the single systems produced. Depending on the wafer material, the thickness and the application, the process parameters are optimized for chip quality, which could, for example, mean reduced edge damaging, also known as chipping. While wafer dicing might seem like a small step, it plays a central role in the journey from a whole wafer to a single system on a chip. Thank you for joining us. Subscribe for more insights into the world of microproduction technology and innovation. If you're passionate about science and engineering, consider exploring opportunities at the Leibniz University Hannover.